All right, so I've been getting a lot of messages about our last video on Friday, those of you who watched it, that there's a bit of confusion. So I wanted to go over the try on your own example and try and reiterate, because I know that we only really went through one, but it was a lot of information. So we're going to have a couple more practice problems today. So first and foremost, domain. Do recall that the domain if we move from left to right, let's go ahead and take this as my little eraser, and I'm going to go moving across from left side until I hit, my function. All right, so as I take a look here, since I'm doing domain, I'm going to use blue. There we go. I'm going to scoot it over a little bit. I have here a solid dot. Oops. Oh, goodness, that was really, really bad. So let's try that again. Maybe with my... There we go. That one looks a lot better. I had to use my touch screen. Okay, so here I have a solid line, a solid dot, so that means I am including that value. And it begins at, let me move that back over here to be less confusing, -2. Okay, now, because it's a solid dot, recall that solid dots, let's see if this will draw out okay. Pretend that that's all filled in. Solid dots we're going to say will be less than or equal to. But open dots, ooh, that looks bad. That we will say will just be less than. The equal to means I am including the value. Domain values, just like we had said earlier, are x values. So there we go, x. And we're going to keep moving across. And what we're doing is we're pretty much following this line here, okay? So we started on the left side, and we're just going to keep moving up, 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 up. Right here is where we stop at. And that was nice. I gave you another solid line or a solid dot. And this is actually ending at +4. So the thing is, because I am including that value, remember, that means I'm going to use my less than or equal to. Now, whenever you're doing continuous domain and range, this is pretty much our formula. Number, inequality, variable, inequality, number. That's really it. So I'm going to go ahead and erase it out, or sorry. Now, whenever we're talking about my domain, I'm talking about all of these x values. As a matter of fact, these x values right here. Now, I'm saying that if I were to pick out a number like right here, that's a decimal. That's approximately -1.5, 2.5. I'm saying that I'm including all of these possible x values, even though it looks like it's going up. Yes, I don't care about going up, though. I only care about these x values that they are attached to. So, there you go. Clear it off. Now, let me put that back on. All right. So now let's talk about my range. Let's go back to our video, our presentation. So range, we had said, we will read range or the y values, which is the y-axis that goes up and down, from the bottom to the top, or you can say bottoms up. It's like planting a tree. It grows up, okay? So taking a look here, I'm actually going to get my little timer here, and I'm going to start at the bottom and just chug my way on up until I meet something here. So that would be another solid inclusive value at -3. So let's write out that -3. Now, because it is an inclusive, it's a solid dot, I would refer back to these notes that I accidentally erased. Since I have a solid inclusive dot, I would write less than or equal to. And remember, since we're talking about the range, we're following my y-axis. Sorry, there we go. So I would also write down y. So right now I'm talking about all the values starting at -3, and we're going to move it on up. So we're just following this all the way up until we reach the very top. So let's highlight that. And oh, hey, that was nice. I gave you another solid dot there at +4, it looks like. Now, because it's a solid dot, again, I would say it is inclusive. So that's kind of really it. You just have to follow the pattern. Like I said, number, inequality, variable, inequality, number. Now this inequality here, it's attached to the -3. So if I have a solid dot with a -3, I'm going to write the less than. Just like here, this inequality is attached to the 4, which was also a solid dot. So overall, what I've done by describing both my domain in blue from left to right and my range from bottom to top, I have enclosed this representation by my domain and range. Now, if I did not have a domain and range, that would mean this line would probably go on forever, but I am enclosing it within this certain area. So now let's try something a little different. This time, what I'm going to do is I have already given you my domain. All right. And I'm going to highlight this first section, and then I have a second section. Now, what I've asked you to do on your activity is to sketch a graph of a linear function. Remember, that's a line with the indicated domain or range. So you're going to be doing yours in Desmos, so you can literally sketch all you want. Oh, I love Desmos. It's so cool. But obviously, you don't want to do anything that ugly. So let's go ahead and actually begin, just like I had stated with this part right here. Here it's saying -3 is less than x. So let's actually recall the information I had stated earlier. Inclusive means to include. That's why we will use our less than or equal to sign. And exclusive means to exclude. That means we have an open circle. It's not including this value. That's why we have the less than symbol. So let's take a look back. So since I have this less than symbol, I already know I should have an open circle at -3. So I'm going to put a little open circle at -3. Now, remember, I'm talking about my x-axis over here, all right? So let's go to my x-axis and find -3. Okay, here we go. And I'm going to put a circle around it just for right now. Now, let's change slightly our color. Purple, why not? Now I have my second portion right here. Now this time it says less than or equal to 4. So the difference there is, there we go. That means I'm going to have a solid dot at 4. So right over here. Now, a linear function, remember, it's just a line. Most of the time it's diagonal, which means it goes sideways. So I can honestly put my -3 anywhere here. My y value doesn't matter whatsoever. So I'm going to erase that right there so that I can come back with my blue. So let's say maybe I have an open circle at, ooh, that looks ugly. There we go. Ooh. At negative 3, 2. Why not? Now, is the x value here at negative 3? Yes. I mean, I could have had it here or here, or you know, even if I wanted, I could have had it at negative 2.5. It doesn't matter, okay? What matters is that my x value, you know what? I like that circle more, is at negative 3. So now let's deal with this purple 4. I need a solid, there we go, a solid dot at 4. Now, I have two options. I can either make my line go up or come down. You know what? I think it'd be kind of cool to go down. So I'm going to try my best to fill that in. Whew. All right. Now, because that was just god awful, I'm just going to draw my line from here to here and connect it. Oh, thank goodness. Okay. That didn't turn out so bad. Oh well, whatever. So I created a linear function. It looks like a line, and it has a value. It begins with an exclusive value at negative 3 and an inclusive value, that means solid dot, at 4. Do my y values matter at this point? No, they don't at all. But let's move on to the next one. Now, this is being very specific. Well, actually, no, because all this really has to do with is range. So it's not too bad. So let's do the first part. So I have 1 is less than. Now remember, we're dealing with my y-axis this time, okay? So I only care about these numbers. As a matter of fact, you know what? I'm gonna do this. Don't kill me for this. I don't care about that. There we go. Or those numbers either. I don't care about them, okay? We only care about y values this time. So I want an exclusive, so that means an open circle at positive 1. Okay. Well, let's see. How about 1, 1? Why not? I'm going to put an open circle there. I swear that's a circle. Okay, so now let's go to the other side. This time I have y is less than or equal to 4. So that means that I need a solid dot at a positive 4. Well, I already put this dot over here. I think it'd be kind of weird for really short. So how about let's put it over here. Why not? There we go. All right. And let's connect them up with a line. So now you'll notice I created a range where going from bottoms up, so starting at the bottom, boom, I have positive 1 right here, and then boom, and I end at a positive 4. Now notice that the open dot is at the 1 value. That's why I'm not including the 1, but I'm including everything larger and up to 4. Okay. Now, this challenge I'm going to leave for you guys. Now that I gave you an example of how to do a domain, to sketch out a domain, and I gave you an example of how to sketch out a range, now here's the challenge. They want you to put it together. Okay, so now everyone can have a different sort of line here. If you're following my steps that I did for these past 2 slides here, then your 4th slide should look different from your classmates, and that's okay. You can have several different answers. You just need to make sure that all of this is correct. Oh, actually, I think that was a little typo. I'll make sure that I write that in correctly. All right, so that will be for you guys. All right, give that one a shot. Once you've done that, you'll notice that your next 3 screens might be a little bit easier for you to do. If you want to go back and forth and you want to do some of this practice first, you notice, oh, hey, I have multiple choices, and that makes you feel a little bit better, then all right, you'll notice they look pretty much exactly the same. Okay, so that's where you really have to know the difference between domain and range and X and Y values. Okay, you have 1, 2, 3 multiple choices. And then I have these. So I gave you 3. Here's a quadratic function. I want you to type out here the domain and range. All right. There we go. And that's actually it. So what I'm going to do is, there have been a couple of y'all that have been asking for help. I'll go ahead and wait to find out what time tutoring would be best for y'all. And I'll do one of these with you guys during tutoring. Okay? So if you want that upper hand, please email me, because I get a million private messages from you guys and they get lost because everyone's typing present here. So best way to get a hold of me is either email or send me a text here and remind. All right. I have 1st, 3rd, and 8th period for geometry, and 4th, 5th, 7th, and 9th. Make sure you join the right class, but it really doesn't matter. You can send me a text. All right. Best thing I love is that you can send me a text. Send me a picture of the sort of problems that you are having. And what am I going to do? I'm going to send you back a reply. All right. I can write everything out, send it to you, and it's a lot quicker texting. All right. If you need help getting started with Remind, please go to my website. All right. Remember, it's in every single one of y'all's class name right here, http://goo.gl/speffy9. Highlight it, right click, and click go. All right. Whenever you go there, immediately you're going to have the syllabus for both Geometry and Algebra 1. So if you just hover over one of these, it will send you over to Remind, and you can get signed up, put in your name and your phone number, sign up. It's that easy. All right. I really try and make things easier for y'all. So please, if you guys need assistance finishing out these last 3 problems on your own, please reach out to me. Texting and emailing will be quicker, and we can set up tutoring so that you can get a better grasp on this, because we do need to move forward. And your practice on Tuesday is going to be both continuous, remember continuous is connected, and also discrete functions. Okay, so I'll see y'all then. Hasta luego.